Everyone. This is something that I don't do usually, but I've seen making videos actually help me to learn the concepts in depth. And since I need to be like super clear on what I am saying, I like try to read more and try to understand logic behind things before presenting it. So I figured out this topic on internet that I was interested in, and I thought of making this video and trying to understand uh, like the logic behind this topic. Since most of my work has always been in text, natural language processing, I was wondering how the multimodal information retrieval system works, or how does it take place. And I even have built some projects around, but those were like independently, like let's say on only on audio or only on images. So yeah, this is what a basic RAG application based on text look like. I think you guys must be aware of, because it's a very basic thing. So given a query by the user, you simply convert them into embeddings. Embeddings is just some number representation, or you can say some higher dimensional number representation, where those text mean some sense in numbers, and you take that vector and you kind of do some similarity search between the vectors of the database, that is the data pool that you have from where you're trying to generate a response. And that this similarity gives you a context, that is the most relevant context out of this database for the given query. And then you simply pass it to LLM, and then you get a response generated by LLM. And this is the basic text track. Moving on to the images, the pipeline, image or audio or any kind of modal, the pipeline stays pretty much same. The only thing that changes is the vector representation of that modal. So in case of image, you might be having the vectors of image or audio, and the representation is taken care by the embedding model itself. So it's just maybe you can toggle between modals, and you can query that on natural language, and you'll be good to go. And yeah, these are some projects that I have worked on. But let us scale and look for multimodal RAG. So modals can be image, tables, text, and can be signals, and maybe some any other form or format of knowledge base. So excuse me. Yeah. So multimodal RAG. So there are two ways to do it. So this is from LangChain's blog post that I found, where you can query the data based on the raw form of the data. So you simply like vectorize using some vectorizer, and you have the raw form inside your database, and you query and you get a response. So this also has a use case. Let's say what Gmail still does is it is based on the raw data. So let's say you have keyword. It's the search is based on keyword. So uh, I think that's not case sensitive, but it is based on normal Boolean information retrieval system. So if you had a typo, you won't be able to, or you have some different form of word, you won't be able to retrieve the mail that you are looking. Same is the case for, let's say, Hugging Face, but the uh, I think the query is case sensitive. So in cases where you are bound to know the thing that you are retrieving, such systems does make sense. So uh, this is the one approach. That is the option one. For option 2 and 3, what we're trying to do is, let us say if you have a very diverse data pool, and let's say the data sets in the benchmarks, where the benchmarks that we are using to benchmark the responses of LLMs, so it vary quite a lot. So in that cases, we might not directly use the raw form of the data. We use a summary of the data. So the summary can be generated by LLM, or if you have human annotators, or if you have the data set already, then it's good. So you use a summary to kind of uh, extract more and more information or knowledge from the given, let's say, image of Mona Lisa here. So you can extract or ask LLM to generate a summary of the image. So the next time you query, you have a better understanding of what the image or any form of the modal is trying to represent, and then you can query over using the simple RAG, and you will be able to retrieve either the raw form of the image or very summarized form that you can get from the summary of that modal. And yeah, this is it. So for embeddings, there is this one model called Clip. This was by OpenAI. There are like numerous embedding models, but uh, so you might be either so there are like numerous use cases. You can either simply embed the raw image or raw text independently, or you want to, like, if the image you have a, like, let's say, caption of image, you may want to, like, embedding both of them, embed both of them together. So this is just one model where it's a encoder based model where you simply have images and classes, and you input the model with given the image, like which class this belong to, and if from this representation, the model figures out and gives you a class of, okay, hey, this is the photo of a dog. So this is just one example, but there can be numerous use cases where you might be using some other embedding model. So that is something that is custom for your use case, and that is something you need to figure out. There are thousands of options on Hugging Face embedding models. This is the MTB leaderboard. I think this has changed a little because 2-3 days back there was no graph representation, but I see this is something that they have updated in, I think, this week. The next thing I was looking to is, I think I have covered the basic RAG thing and the information retrieval systems, but the main thing that caught me was the word intelligent, because uh, what can be, or like, what is the significance of being an intelligent information retrieval system? So for let's say the use cases of YouTube videos, lectures, and slides, when the scale is limited to a small sample space, then I think you can simply query a whole video, or you can have all kinds of representations inside, and you can simply query and you'll get a result. It is optimized because the sample space is very small, and you get your responses very efficiently. But for scaled systems, let's say you have thousands of videos and audios, and from that you query like a question, then a system might fail because you won't be querying 1,000 videos in real time and then generating response. uh, that might be case, might not be the case, but I think the word intelligent triggers there's more to look into information retrieval systems to make them intelligent. And like, I was thinking of this case where, let's say you have 1,000 videos of football matches spanning over, let's say, 1 decade, and you're querying, so in that case you won't be querying all the years of the data, or all the structured data that you have in your memory. So because loading that might you might not have that much capacity to load all the space into your memory. So there, I think we can have some sort of a classifier where, let us say I query, I want to see a match of 12. The question is the match of 2012, when was the goal, when did Ronaldo like goal. So from this question you can simply add a layer of basic classifier where you can look up, or basically look up from the metadata that okay, these are the metadatas that I have, and maybe this query can help us sort of segment the data pool that we are interested in. So in that case, the model that we're using will be very efficient, and I would say fast, because then you are not querying the whole data pool. You're simply looking into the data pool of your interest. So this is just one use case. uh, some other query could be this, but let us say if we do not have the year, and that is a normal query, then how do we segment? uh, I think during the data annotation or data ingestion, when we try to curate data, we can reverse engineer things like having metadata or tags into the metadata, uh, which might be relevant to the user's query or the user's intent. So let's say if our system aims to retain the emotions also of, let's say, the input, the data that we have are videos, and we intend to also capture the emotion or the facial expression of the person, then we can simply extract frames and add meta of emotions, or any other representation that we're trying to focus on, and add that into metadata. So in that case, we can simply use this query to kind of segment that into somewhere which it aligns with our metadata. So when you query, you can get your responses normally also, but in this case, the intelligence would be re-ranking the system, or re-ranking the chunks based on the metadata of our interest. So in that case, I think the retrieved chunks would be much more accurate, because that aligns with the tags, let's say India. So you might want to add it in the ranking itself, or you might want to re-rank after getting your responses. So this is something that is again dependent on the use cases. Let's say in case of some research papers, I want to query first and then re-rank the responses based on the year of publication, because like as the time goes, there are like contradictions or contradictive theories built on like same topic. So there I want to re-rank just on basis of year of publication. So there the meta of tag might not be relevant, but in case of, let's say, news and matches, or anywhere relevant thing, where we can simply perform this fashion. And yeah, that brings us to end of the presentation. Yeah, feel free to drop your questions, and I'll add the relevant things in the video's caption. Yeah, thank you.